Consider a ship moving ahead and pushed by a lateral force at the aft end of the ship. The lateral force applied to the ship moves the ship in transverse direction, while the thrust acts in the forward direction. Due to the combined forces, the ship turns about a point called pivot point. It is approximately 1/3 from the forward of the ship. When a ship turns port or starboard, the lateral force is provided by the steering gear system. The steering gear turns the rudder to required angle as per the helm order. Consider the forces acting on the rudder. On one side of the rudder, the flow velocity reduces in speed, while on the other side, it increases due to the angle of incidence and shape of the rudder. The decrease in flow velocity increases the pressure, and the increase in flow velocity decreases the pressure. A force F is produced due to the high and low pressure regions generated by the water flow. The total force generated acts at a point on rudder called center of effort. The longitudinal component of the force is called drag component. The transverse component of the force is called the lift component. This causes the ship to turn. The torque imposed by the water flow is the force on the rudder multiplied by the distance from the center of effort to the axis of rotation. The torque exerted on the rudder is overcome by the steering gear hydraulic actuator, and the ship turns. The conventional rudder is effective to a maximum angle. After this angle, the lift force decreases considerably and the drag force increases greatly. The rudder then acts as a brake. This stall angle for an aerofoil-shaped rudder is approximately 37 degrees.